So you already studied about the liquids and the gases in the class 11th. So states of matter, right? So especially only the solid state you'll study in the class 12th, that is inside the first chapter. So if you are preparing for the exams like JEE mains and the advanced, especially from this chapter you'll get the numerical problems. Okay,
Okay, sir.
mostly it will cover only numerical problems, only like density formula, especially will come mostly on the density formulas only. Okay, 1 minute please. So just wait a minute. So when you're speaking about the solid state, generally if you prepare for the board exam now, it will come total 4 marks. Okay, one very short answer question and one 3-mark question. But when you're preparing for the JEE level, definitely you'll get the numericals mostly from this chapter. Can you hear me properly?
Yes, sir.
Yeah. So when you're preparing for the board exam, you'll generally will get the numericals. Sorry, for the board as well as for the JEE and all, you'll get the numericals, especially on the types of units like FCC, BCC, ECC, okay, or the density formula, are based upon the octahedral words, tetrahedral words. We have so many formulas will come in this. I hope everyone knows what is the FCC and all. What is the definition of FCC? What is FCC? Answer please. What is the ECC, FCC? First, what is a unit cell? Just raise your hands. How many of you studied this chapter in your schooling? It's already finished in your school. No one. Unmute yourself and you can say the answer either yes or no. No problem. I'll not scold you if you say the no wrong answers in the class also. I am there here to help you only, right? Jafar,
Yes, sir.
you know the meaning of these things or what is the
I
meaning of
read it very
FCC?
I read it
Yeah.
very long back, so I don't remember, sir.
Yeah, it's okay, fine, no problem. Just we'll recall once again. No issue in that. What about Ramcharan Teja?
Not properly, sir.
No. Kept the hero name. Nice. You are Telugu?
Yes, sir.
So classification of solids. So first I'll write all the side headings in this topic. What are the topics we are going to discuss in this chapter? First I'll mention all the side headings so that when you're going for the revision also, if you read this first page itself, you'll get an idea about the complete chapter. Understanding? So this is like a mind map. So if you see the properties of solids, what are the properties are there? Generally you study in the class 10th and all, right? Definite shape, definite volume. They have the high densities, incompressible in nature and all. Like that, we'll go to the next topic, like types of solids. So again, the two different types of solids, amorphous, crystalline and all. So next one is the classification of solids like this. So generally it will give us the, first I will write all the side headings important in this chapter, like overview of the chapter. Then we'll go detailed into one by one. Is it fine?
Okay,
Yes,
sir.
sir.
Okay. Okay. So next one is first one is the properties of solids. Next one is the types of solids. So again, types of solids are two types: amorphous solid and the crystalline solid. And the third one is the classification of solids. In that we have the metallic solids. Okay. The next one is the covalent solids or network solids. Third one is the molecular solids. Fourth one is the ionic solids. Okay. So in this molecular solids, again, we have the different types: polar, non-polar, and the hydrogen bonded solids. So these are the complete classification of solids. Total, you have the four different types are there. Okay. So metallic, which means only metal atoms will be form the solid structure. And the covalent means, non-metals generally will form the covalent solids. And the molecular means the constant particle in the solids will be the molecular, either H2, Cl2, these things. Again, the molecular solids will have the polar, non-polar, and the hydrogen bonding. And the last one, about the ionic solids, based upon the ionic bond that is between the metal and the non-metal. So all the four different type of solids will have the different type of molecular interaction. So based upon the molecular interaction only, they are classified into four different types of solids. Fine.
Yes, sir.
Okay. So next one is the space lattice or the crystal lattice. So in this we'll study about the lattice point, lattice sites and all. The next one is the unit cell and its parameter. So what is a unit cell? What are the parameters of the unit cell that we will study in the topic number 4? That is the space lattice and the crystal lattice. Next, fifth one, types of unit cells. What are the different types of unit cells are there? Okay, the first one is a primitive. The next one is a centered. Primitive means it is a simple unit cell. That means only atoms will be there at the corners. Okay. Like again, these are the 7 different types are there: cubic, trigonal, tetragonal, hexagonal, and the triclinic, monoclinic. So any one of you can tell me what is this? All the things. You already studied in the school or not, Ram? Whether this chapter is done or not. Ramcharan, are you there?
Yes, sir.
Whether this chapter is completed in your school or not?
Yes, sir. Done in the online.
Finished. Say openly, no problem. If you have already finished the chapter, if you have not understand now, I will help you. I'll teach you completely from first to last.
Sir, when we were in the online classes, it was.
Okay, when you're in online classes, that's done. But you're not thorough in the chapter, right?
Yes,
Okay,
yes, sir.
no problem. But after completion of the chapter, we'll have some exams. You have to get the good score. And if you have any doubts during the class, you can stop me and you can ask me at any time. Okay?
Okay, sir.
Class should be always interactive only. I don't want to teach only from my side. When you have the doubts, you can stop me at that time and you can ask me. Okay? Feel free to ask whatever the doubts you have. So next on the types of unit cells, you have the primitive and the centered. FCC means face centered unit cell. BCC means body centered. ECC means end centered. Okay, again the sixth one is the solids. So again one dimensional, two dimensional, and the three dimensional. So these are the three different types of packing in the solids. Next, seventh one, we'll discuss about the packing efficiency, or also you can call it as a packing fraction. Okay, so this is a packing efficiency. So we have the four different packing efficiency in the CCP, in the FCC, in ECC, and the HCP. So these are the packing efficiency in the different types of solids or the unit cells. And now the theory part will have one is the electrical properties of solid. Next one, defects in solid. This is also theory part in solid. Again, the two types, stoichiometric and the non-stoichiometric. So in the stoichiometric case, we have the four types again. Frankel and the Schottky. Next, vacancy and the interstitial. Jafar, do you remember what are the topics we are covering when I'm writing these things, the words?
Little bit I'm getting ideas.
Little bit you are getting the idea. Good. So metal excess and the metal defect deficiency. Okay. And the last one is the magnetic properties. So with this, we'll finish the chapter. So these are the main topics in this chapter, complete chapter, the overview I have given for you. So when you're preparing for the any type of exam, either the board exam or the JEE or the NEET, if you see this first page itself, you should have the complete overview of the chapter. What are the different topics are there? What are the are there? Okay, sorry. We didn't discuss about the density, right? In between the density of the solids also. Classification, not after the classification. So before this packing efficiency, we'll discuss the density formula also. Any one of you tell me what is the density formula? What is the density formula? Anyone?
General terms, it's mass by volume, sir.
General term is mass by volume. Very good. In the terms of solid state, we have the different density formula is there, right? In terms of Z and in terms of molecular mass of the solid and volume of the solid and the Avogadro's constant. So that is different. So generally I will write it here itself. Density formula, it's very, very important for the exam point. Z into M by A cube into NA. That is the density formula. Okay, so these are the side headings are there in this chapter. So first we'll start with the properties of solids. Now we know what are the different properties of solids. What are the different properties of solids? Which you know very common. Can you hear me or not? Guys. You'll study in the lower standard, right? What is the meaning of solid, liquids, and the gases? Solid means what? It will have the definite shape and the definite value. So it will have a high density compared to the liquids and gases. The particle inside the solid is very, very close to each other. So there is empty space at all between the particles in the solids. Okay. So the particles will not move at all from one place to other place because there is no empty space at all, right? For the movement of particles. So they will not move at all from one place to the other place, but they will vibrate in the same position. And if you take the solids, generally they are incompressible in nature because of absence of empty space between the particles. And the intermolecular force of attraction is very, very high in the case of solids, gases. Points about the general properties of solids. These are the general properties for the solids. Any doubts in this? Which you're already studying from the class 6th, 7th, 8th, 9th, 10th, right? About the solids, liquids, and the gases. Any doubts in this?
No, sir.
Okay. So next one we'll study about the types. Like Sir is only saying he's not writing anything and all. That's what I didn't mention you. I didn't. So next one is the types of solids. So again, we have the two different types of solids. One is a crystalline, and the next one is a amorphous. Okay. So here we'll write the property. So first one, we'll start with the example itself. That's better because remembering the properties with the example is easy. So if you take the crystalline solid, we can take an example as a diamond, and the amorphous solid as a talcum powder. Or simple, you can use glass. Is amorphous solid example. Now we will study the remaining properties of the crystalline solid and amorphous solid with respect to these two examples, so that it will be easy for you to remember. The first one is melting point. So what is the meaning of melting point?
Temperature at which the particular substance starts melting.
The temperature at which the particular substance start moving from solid to liquid state, right? So if you take the diamond, whether it is having high melting point or low melting point.
Very high melting point.
Very high melting point. Good. So crystalline solids will have the high melting point. Okay. And we can say they have the fixed melting point. That means at a particular temperature only they will start melt. Below that temperature, it will not melt at all. Or also, it will not be in the solid state. So melting point of the crystalline solid will be very high and it will be fixed in nature. The next one, amorphous solid. Now tell me the glass. Suppose you are heating the glass, it will have the fixed. whether it will have the fixed melting point?
No, sir.
No. So the melting amorphous solid is low and it will varies according to the substance. You don't have the fixed melting point, it will vary slowly. If you take the plastic, it will all melt exactly at one temperature, right? First, it will become the soft, then it will become slowly into the semi-liquid, then it will start into the liquid. But if you take the crystalline solids, they have the high melting point, it will have the fixed temperature. Immediately after the temperature, it will start liquid. Understanding the difference?
Yes, sir.
The next one is the cleavage property. Whether my handwriting is clear for you?
Yes, sir.
Yes.
So cleavage property, that means when you break the crystalline solid, you'll get the sharp edge or the smooth edge you'll get. But at the same time, when you break the amorphous solid, you'll get the uneven. So whenever you are breaking solid or whenever you are cutting into the two pieces, there will be smooth surface on the cutting side. That's the crystalline solid. Or they have the sharp edge. That's the crystalline solid. But when you compare amorphous solid, they don't have the sharp edges. That means always it will form the irregular surface. Okay, that is the amorphous solid. The next one, heat of fusion. What is the heat of fusion? You know the melting point, right? At a particular temperature, the solid is converting into the liquid state. Same way, the heat of fusion is nothing but the amount of heat absorbed by the solid at its melting point. Okay, amount of heat absorbed by the solid at its melting point is called as the heat of fusion. So what is the heat of fusion? Amount of heat absorbed by solid at melting point. So whatever the heat is absorbed by the given solid at its melting point is called as heat of fusion. So if you take the crystalline solid, you will have the high heat of fusion, and the amorphous solids will have the low heat of fusion. Okay, the next one is the nature. It's very important. It is anisotropic in nature. It is isotropic in nature. So any one of you can read what is anisotropy and what is isotropy? What is anisotropy and what is isotropy? What is the meaning of anisotropy and isotropy? Anyone? So if you take the physical properties, so what are the different physical properties will be there? Plasticity. The next one is elasticity or melting point, boiling point, and if you take some solids also, it is a refractive index. These are the physical properties. Okay, just wait a minute. 1 minute, please. What is the meaning of anisotropy and isotropy? So when you take the physical properties like plasticity, elasticity, and the melting point, boiling point, and the refractive index, these are the physical properties. If the physical properties are different direction inside the solid, that is called as an anisotropic in nature. Anisotropy means what? What is the meaning of anisotropy? Physical properties are different in different directions inside solid is called as an anisotropic in nature. Suppose if you take particular solid like this, we'll take this as a bigger only. If you take particular solid like this, it will have the different physical properties in the different directions like this. So if they have the inside the solid itself, you have the different physical properties in the different direction. That nature is called as an anisotropic in nature. Isotropic means what? Same physical properties in the different direction. Is it clear?
Yes, sir.
Okay, so crystalline solids are anisotropic in nature, which will have the different properties in the different direction in the solid, and amorphous solids are the isotropic in nature, which means they have the same physical properties in different direction in the solid. That is the main. So next one is the order of arrangement. Now tell me which one will have the long range order and which one will have the short range order. Which one will have the long range order and which one will have the short range order? Which one will have the long range and which one will have the short range? If you take the crystalline solid, you'll have the long range order. That means for the longer range, the particles are arranged in the regular fashion. So this will have the long range order, this will have the short range order. Okay, so if you take the anisotropic, this is a crystalline solid. If you take any particular direction, it will have a particular range like this. The order of arrangement of particle will be in the regular pattern in any direction like this. But if you take the amorphous solids, they have very short range order. Even though atoms are very closely packed, there is no particular order of arrangement of particles. Okay, so this is a amorphous solids. You can see the difference, right? Here all the atoms are arranged in the regular pattern in different directions. But in the case of amorphous solid, the particles are there, they're very close to each other, but there is no order of arrangement at all. That means the order of arrangement is very less compared to the crystalline. Understanding the difference between these two now? Any doubts in this? Neha,
No,
good
sir.
evening. Neha, unmute yourself. So these are the types of solids we have. Neha, unmute yourself. And Vishwanath also, unmute yourself and speak. So these are about the types of solids. So next we'll study about the classification of solids. But before that,